Hello, this is Dr. Amudapriya, Associate Professor Tripli, Rohini College of Engineering and Technology. We are discussing about the course Power System Operation and Control, and in this lecture we will discuss about the optimal operation of thermal units. So what is the meaning of optimal? Optimal is nothing but either minimum or maximum. So regarding cost, it has to be reduced. So the process of achieving the minimum cost in operating a satisfactory level of operation when it is executed in case of a power system with the minimum cost, that cost is known as optimum cost. So in power generation, our main aim is to generate the required amount of power with the minimum cost. Economic load dispatch means that the generator's real and reactive power are being allowed to vary within certain limits so as to meet a particular load demand with a minimum fuel cost. So this can be obtained by proper allocation of loads, but there should be some constraints. So while considering an optimality condition, how it has been achieved is we should have an objective function together with certain constraints. So let us consider the inequality constraints first. Actually there are two different types of constraints, namely equality constraints and inequality constraints. Here we do have the inequality constraints. Both we do have voltage constraints and the generator constraints as such. When running the spare capacity constraints, those also, because running spare generators are being necessary, and then we do have transmission line constraints, transformer torque settings, etc. These are the obvious conditions which has to be considered while designing a system. While considering the operating cost of a thermal power plant, the factors which influence the power generation at minimum cost are the operating efficiencies, and we can see how it is being considered. For the first case, let us neglect the losses. So it is the simplest economic dispatch problem. Assume that the system is only having one bus with all generation and loads connected to it, and the cost function, that is the objective function, is considered as Ci. So Ct is nothing but the summation of all the generators cost. So it is Ci. Let Ci be alpha I plus beta I Pi plus gamma I Pi square, which is a quadratic equation, right? So in this quadratic equation, the parameter which is varying is nothing but the power Pi. Rest others are the constants. Alpha I, beta I and the gamma I are the constants which are going to determine the influence of the power. So this can be minimized. The cost Ct can be minimized with the constraints of the total summation of Pi is nothing but the total power demand which has to be met. And by Lagrangian multiplier method, we can obtain this equation. We have to differentiate it with respect to both the parameters, with respect to lambda, Lagrangian parameter, and with respect to the power. So while considering the first equation, how does we result? And then we have to find out the condition for the optimum dispatch. So while considering that, we used to get beta I plus 2 gamma I Pi is equal to lambda. Upon substituting that, we will get Pi value, and also the summation of Pi value will give you the Pd value, from which we can determine the analytical solution of lambda, which is nothing but the Pd plus summation of I is equal to 1 to Nt beta I by 2 gamma I divided by summation of I is equal to 1 to Nt 1 divided by 2 gamma I. While considering the iterative technique, we will have summation of I is equal to 1 to Nt Pi of k. So Pi of k, this is we can find out the power mismatch here. What is the change in power between the Pd value and the total summation of the actual value? With this, we can obtain the equation of lambda, I mean the next state value with the present state value and the change in lambda value. Next, while considering the losses, we can have PL is equal to summation of I is equal to 1 to Ng and summation of J is equal to 1 to Ng Pi Bij Pj. So what we are going to consider is, when a power is transmitted over long distances, transmission losses are a major factor that will be affecting the optimum dispatch of generation. So we are going to include the effect of transmission losses and this as a quadratic function. So the coefficients Bij are nothing but the loss coefficients of B coefficients. While considering this, we have to redraft the equation as such, and here comes the inequality constraints of the powers minimum and maximum value, and then you have to find the Lagrangian multiplier, and finally we have to differentiate it and equate it to 0, that's the minimum value, and then finally we'll be getting the equation as such. We have to find out the penalty factor and the lambda value. By iterative method we can find the del lambda k, and this when substituted we can find out the lambda k plus 1. As such, when lambda k plus del lambda k. So both the derivations are same as though we consider the losses in this case. So repeating the procedure of the lambda, we have to repeat until the power mismatches within the limit, and finally we will be getting an optimal operation of the required number of thermal units. Thank you.